In our next problem, we are given with an equation in x and y as under root of 1 minus x square plus under root of 1 minus y square is equal to a times x minus y, and we need to find dy by dx as something as under root of 1 minus y square upon 1 minus x square. Now in these type of problems, most of the students will start differentiating the given equation, but this is not a good method. The substitutions which we do in this chapter are very useful because they help to ease out the problem. So very clearly we can get the substitution as x equals sine theta, because here there is a formula of under root of 1 minus x square. So the first substitution which comes in our mind is either x equals sine theta or x equals cos theta. So we start with x equals sine theta, and similarly we do y equals sine phi. So this becomes cos theta, this becomes cos phi, and this becomes a times sine theta minus sine phi. Applying the formula, we get 2 times cos of theta plus phi by 2 into cos of theta minus phi by 2 is equal to a times 2 cos theta plus phi by 2 sine of theta minus phi by 2. 2 and 2 cancels. On cancelling this factor, we write cos of theta plus phi by 2 equals 0 equals cos of pi by 2. So theta plus phi equals pi. Sin theta is equal to sine of pi minus phi, which is equal to sine phi. Sin theta is x and sin phi is y, so we get x equals y. But putting x equals y in the given original equation, we get 2 times under root 1 minus x square, which is a positive quantity equal to 0, and we know that a positive quantity cannot be equal to 0. This is the mistake which most of the students do. The solution they get, they don't check the given equation with the solution which they get, and hence they commit mistake. And sometimes they find one of the solutions as dy by dx equals 1. But one thing you should remember is that whichever solution you get, you should put in the original equation to check whether it is satisfying the equation or not. So this is not satisfying, so we reject this solution. So the other solution which we have is cos of theta minus phi by 2 equals a times sine of theta minus phi by 2. So we get cot of theta minus phi by 2 equals a. So theta minus phi equals 2 times cot inverse of a. Now our theta is sine inverse x, as we substitute sine x equals sine theta, and our sine phi is equal to y. So phi is equal to sine inverse y. So writing the given equation as sine inverse x minus sine inverse y is equal to 2 times cot inverse of a. Now differentiating this equation, we get 1 upon under root of 1 minus x square minus 1 upon under root of 1 minus y square dy by dx is equal to 0, and hence y dash is equal to under root of 1 minus y square upon 1 minus x square, which is our desired result we needed to prove. So one thing we should remember from this question and learn from this question, that as soon as you see a question, don't start differentiating it. Just analyze it for a moment and see what substitutions you can make in the question to make it simpler. Hence the final answer is under root of 1 minus y square upon 1 minus x square.